All right, pre-calc, we're talking about functions today. Let's get going. We're in lesson 1-2, and we're talking about functions. Now, some of these definitions get a little wordy, so I'm just going to read it to you, and we'll describe it from there. Function f from set A to set B is a relation that assigns to each element x in the set A one element y. Typically, the domain is the input, and we use that as the x value. Range is the output, and we use that in the y value. So let's go ahead and see what they mean by functions. Let's go ahead and look at example 1, letter A. They're telling us the set of A is 2, 3, 4, 5, and the set of B is -3, 2, -1, 0, 1. Which of the following sets of ordered pairs, which is a relation, so notice a relation is like these little squigglies, and all the ordered pairs inside. So we have 1, 2, 3, 4 different ordered pairs. And it says which represent functions. So we're looking for something that represents a function. Well, let's look. We have a 2, a 3, a 4, and a 5 in our x domain. If it is not repeating, meaning it's only shown here once, then it is a function. Now, if I was to take all these points and graph them, +2, -2, +3, 0, +4, 1, +5, -1, we can use what we call the vertical line test to show that it only touches one time. It only touches one time. So that's really, you probably did the vertical line test a lot more in Algebra 1, but let's go ahead and look at the next one. Really, all I need to look at are my x's. I have a 4, a 2, a 5, a 3, and a 2. Well, since we have two 2's, this is not a function. Moving on to the next one, let's see what we have. We have a 2, 3, 4, 5. Now, some people might say, but there's -1s. Yes, but that is the range. Remember, it has to be one set of x with a y. Okay, so we just can't have that vertical line test fail. So if I was to graph all these, it would still show the vertical line test, so this is a function. Oops, I wrote in my highlighter. I'll write it over it. And for the last one, I have 3, 5, 2. Is this a function? Yes. Now, when you're in pre-calculus, you are to have taken Algebra 2, and it might be hard for you to remember what this graph is. X squared plus y squared equals 8. So remember this graph, x squared plus y squared equals 8, is the graph of a circle. Because there is nothing next to the x squared and y squared, I know that the center is at 0, 0. And when I take the square root of 8, because remember that this is x squared plus y squared equals r squared. So if I take the square root, I know that the radius is 2.8. So I know it's going to go somewhere near 3. So if the radius is at 2.8, I would graph it like this. Now, you and I both know that a circle will not pass the vertical line test, because notice it hits twice here, it hits twice here. So this is not a function, but the really good reminder of it is knowing this graph is a circle. All right, moving on to function notation. This is one of my favorite lessons. I love teaching this. Notice it says, let f of x equal 10 minus 3x squared. What this is telling us to do is instead of putting in this x, we are going to put in the number 2. So I have 10 minus 3 times 2 squared. Well, we could probably do that in our head. We know that 2 squared is 4. 4 times 3 is 12. 10 minus 12 is negative 2. So f of 2 is equal to negative 2. Let's plug in negative 4. 10 minus 3 times negative 4 squared. Now remember, order of operations does tell us to take this negative 4, so I'm going to write it out. 10 minus 3 times 16, because I have to multiply all of it through negative 4 times negative 4. And I know 3 times 16 is 48. 10 minus 48. And the answer is negative 38. But we get into a little bit more trouble when I have a binomial. Remember that this right here, this x minus 1, is called a binomial. So just like we did before, instead of putting in x, we are going to put in x minus 1. Let's see it. We have, I'm going to write it up here, 10 minus 3 times x minus 1 quantity squared. We do have to do that magical thing called foiling. So sometimes I like to write another one so I could see it. So I know I have 10 minus 3. Well, first terms, x times x is x squared. Outer terms, negative 1x. Inner terms, negative 1x. So that's going to add to be negative 2x. In my last terms, negative 1 times negative 1 is 1. From here, we have to distribute all of the negative 3. Negative 3x squared plus 6x minus 3, and add like terms to get the answer. 10, just kidding, I didn't add like terms. Try that again. Negative 3x squared plus 6x, and we're adding 10 and negative 3, which is 7. All right, great job. We are moving on. All right, great job. We are now going to look at what we call a piecewise function. Let me write that out for you. Piecewise function. And I find a lot of students have a lot of trouble with this. So let's talk about what we do know. We know that we are going to use this top equation of 3x minus 4 when x is smaller than 0. So numbers smaller than 0, negative 1, negative 2, negative 3. We know we are going to use this x is greater than or equal to 0. Sorry, we're going to use 3x plus 1 when x is greater than or equal to 0. So 0, 1, 2, 3, 4, 5. So when I look at the first one, negative 2 is a number smaller than 0. So I'm going to use the green equation. I'll actually write this in green for you. Instead of putting in x, I'm going to put in negative 2. 3 times negative 2 is negative 6 minus 4. So f of negative 2, because I have to use the top equation, is negative 10. Now, for the next one, it is 0. This is equal to 0 because of this greater than or equal to sign. So because of the sign, we're going to use 3x plus 1. Instead of putting in x, I'm putting in 0. 0 plus 1 is 1. F of 0 is equal to 1. The last one, f of 2. 2 is also greater than 0. So I'm going to use this equation. 3 times 2 plus 1. 3 times 2 is 6, plus 1 is 7. So f of 2 is equal to 7.